the copying the process, which is in the nature, and the mimicking the ecosystem level. These are the three ways that you can bring the biomimicry into the innovation. So let's this is the integrating the life biomimicry approach. That there are basically three things. One is nature as a model, which is like creating more ideas and so forth. Another one is the nature as mentors, scoping, change our mindset toward the applications and broaden the solution space and so forth. Other one is evaluating, where nature we use as a measure, protect the for the success and so forth. When you look at again the biomimicry, we can clearly identify the three approach that we discuss, taking the inspiration from the mother nature, one thing. Problem solving strategy we can get from the other one is inventing and innovation and so forth. When you go back to again to the first one, taking the inspiration from the mother earth, there are various ways. What would nature do? We can do when there is a the problem that we have, right? Likewise, what are the process and what are the animal is doing and so forth. So we can get the inspiration from the plant life, inspiration from the sea creatures, and inspiration from the insect and the birds and so forth. That is a one area. The other one is like the problem solving strategy, like the biomimicry taxonomy, organism and so forth. So like say, how does the organism address the challenges that we have in the nature? So how we can get mimic that. The third one is the inventing innovation, right? We can copy the process and the shape of the structure, and especially in the civil engineering structures and so forth. Right? These are the basically three ways that we can do it. So when we have of course, the problem, we design the problem first. Then we can search for the biological analogies. Then identify the appropriate principle from there. Then we can detach the biological model there. We can test, analyze the feedback, and go to the design solution. Anyway, let me again explain with two examples that there you will understand what I was talking about. As we said that there are three seeds of biomimicry. One is a ethos, the connecting, or we call as a reconnecting, emulate. So how these work like that? We'll go to the first one, copying from the nature. That is efficient and innovative by emulating nature's time-tested strategies, and entrepreneurs can develop the efficient, innovative solution that are even more sustainable. I lost the slide. Can I share the slides? Okay, I can. Right, as you see there, because when we look at the animal, we see how their surfaces and so forth. What kind of the utilization that you can mimic that to the whatever we do the production. So thereby we observe the nature. We get it. That is why we call copying the nature. There are some other example like I explained this in the first day also, termite mound. So when you analyze it, we realize that because of the natural model, there are so many advantages like the temperature being constant, or of course not much changing with the outside temperature. Same that we can copy the same ventilation shafts regulating the temperature inside of the building. So then we can build it. So this, of course, this look like much similar to the termite mound, even in the building itself. But we don't see the everywhere similar building. But this concept can be used many factories and many places in order to reduce the temperature within the building and so forth. So this is how the copying will work. Even for the next example, that was again I explained about what happened in the after the development of the bullet train, in order to reduce the sound, how they develop the shape, change the shape of the bullet train, looking at the Kingfisher, right? That is a natural model. So that same shape modified and brought into the Shinkansen, and they realized that the problem was solved because of this change of the shape. So that is a copy. Another one is, this is a civil engineering example. This is very recently in Kurunagala. They want to remove some of these columns in order to have a kind of theater inside. This is already built structure. So they have changed their mind while doing the construction. So of course, this is not, I won't say it as innovation. It is a copying from the nature. Once we reduce this one, we have to distribute the load within the building, because there are a few other floors upstairs, as well as, of course, the load must be correct. You will see that the solution, how we get from we have the same, we don't get the same pattern, but you will see the ones it is completed, right? We copied the same pattern into the structural element and so on. Likewise, but we had a problem. We wanted to replace some columns. So in order to distribute the load within the building, so we get the solution from the nature. Of course, this kind of solution already established one. This is not the first time we did it. But anyway, likewise, just to give you the example, when we have the problem, we can look into the nature, how nature given the solution. That solution most of the time become a more sustainable solution. Then adapting the nature's ethos, the sustainability and resilience, nature's principle of sustainability. And that is very, very important, that resilience can guide business models that are robust and adaptable, right? Especially this many principles like the circular economy and so forth, which is in the natural system, so that we adapt it to our business model. Thereby, we can make our system sustainable and resilient. Even in the construction field, as I'm a civil engineer, I get some example from the construction industry where we extract material and we produce things and distribute and consume, and the end of the day we waste. So, but nature never do this linear economic model. Nature recycle, reuse, right? That's we call a circular economy. Therefore, we can't continue the way that we are doing. We have to look at the nature, and if we use any material, this has no pathway other than the linear economy. We have to get rid of it, and we have to go to the material methods and so forth, which can be go for the circular economy. As you see here, that we bring all the material which can be reused, recycled, and so forth. Then go for the whole system rather than demolition and going for the landfill. We recycle and reproduce the things, and this is we call the circular. These kind of principles we can grab from the nature. The third one, reconnecting with the nature's world. Creative and responsible, deepening the connection with the nature, first in the creativity and the sense of responsibility driving the innovative and sustainable business practices. So we connect with the natural world, put in the daylight and bring in the plant. A classical example is a green building. This is the very, not a green building, this is just a building, concrete jungle. So that these are the most of the building that we have been building so far. Now we understand that you cannot continue. So what the lesson that we can get from the nature? Nature is a green building. I can talk, 30-40 minutes on this one, but I'm not going to do so. But you see a lot of things, and what we have in the nature, we do in the nature daylight. All the animals and the plants and everything ready for the daylight. Only we go for the artificial light. Here, most of the time we get the daylight. And the energy we produce for the fossil fuel, but here nature go for the solar, so that we have the solar panel and create the power, electricity. Rainwater harvesting, right? And the rooftop garden, thereby reduce the, likewise, even the material and so forth, recycling, reuse, inside of many concept has been developed. But all the thing in the greener building concept, we go for the 8 criteria out of 8, 6, like the sustainable size, water efficient, energy, and the material, and indoor environment. These are the most important criteria for the study. Everywhere, what we do, water efficiency or energy or material, we do what is there in the nature and try to bring it to the building. Yeah. So energy and atmosphere. What we do? We do the daylight, cross ventilation. What is that? That is the nature. When we live in the jungle, we go for the daylight. We go for the cross ventilation, not other artificial way of creating. So greener building itself is the imitation of the 100% biomimicry. But there are still problems that we have not understand how to mimic the environment. Right? There are more innovation to be done. These are all innovation. So very quickly research, there we have, this is how we go the innovation, but there always we have the gap, because most of the innovation end up with the more and more disaster. But if you go with the innovation, go with the biomimicry, there won't be any disaster. Disaster means the pollution and so forth. Right? How to build this gap? So without taking the biomimicry into the account, the research activities, whatever we do, there is no sustainability. Everywhere we have the basically 3 pillars for the sustainability. I'll be very quick: environment, social, and economic. Mainly environment side, we have too much innovation to be done through the biomimicry. Of course, social and entrepreneurship. When you think about the nature has no problem. It can survive million years. No plastic, no garbage, anything. Biodegradable, everything in every activity. But as soon as we enter with our research finding, we end up with a lot of plastic and so forth. There is a problem. Right? So when you target each and every places full of environment issues, there we need to find a solution through the biomimicry, how we get rid of this. Socially, we have issues, right? So we have to find out the solution from the biomimicry for these issues. But mainly, we have a lot of innovation can be created for the environment. Economically, we have issues. Even the first day I said how the biomimicry innovation and GDP going to be in 2030. Economic crisis we have badly damaged all pillars of the sustainability, right? We must bring the sustainable development. In order to bring the sustainable development, the innovation to the biomimicry is a very, very important one. For a successful transformation of Sri Lanka, we have to make sure that we protect the environment and social economic growth must be there. There are a lot of innovation have to be taken place. And that, as I explained, we must bring this innovation to the biomimicry. Sustainable solution, green infrastructure, public transport, renewable energy, waste management, waste reconstruction. So building, we must transform with the help from the nature, right? Biomimicry concept, we have to bring it, right? Then for the transport, we have to have the energy sources from the nature, right? In the water sector, purification, we have to understand how the nature reacted, right? The economy can be improved from the most renewable energy. It's nature. Manufacturing, right? Use the local material, nature material, right? Circular economy principle. This is all nature. Sustainable agriculture. So we at the GAP headquarters, we do the research, and what we try to do is basically bridge the gap between the academia and the industry. GAP headquarters is located in the Columbus zone. But our vision is to bring in the green innovation and entrepreneurships, right? We produce a startup and we produce the companies there. This program is sponsored by the Sri Lanka Foundation and the GAP headquarters. In GAP headquarters, we have the GAP Research and Development, where this Biomimicry Center is located. So this is our website. We are continue this series until the 1st of June. You will see the lecturers and so forth. This is the third day. We will be having the first international conference on biomimicry in August. And then we have the 15th International Conference on Sustainable Built Environment in December. We call it the Candy Conference. We have another conference series, is the Colombo Conference, that is on University Industry Collaboration to Sustainable Development. With that, I would like to say thank you. I believe the nature is the best company, the best mentor, and the best example. Thank you. Over to you, Sadiqa. Sadipa, over to you.
Thank you very much, sir. So again, thank you very much, sir, for your enlightening presentation. And again, thank you for coming with your busy schedule for today's webinar. And now it's my pleasure to introduce our next esteemed speaker, Professor Ajith Alwis. We'll continue our exploration of biomimicry and its role in fostering sustainable innovation. Please join me in welcoming Professor Ajith Alwis to the session. Professor Ajith Alwis is a professor of chemical and process engineering at the University of Moratuwa, and he obtained his PhD from the University of Cambridge and MBA from the University of Jayewardenepura and BSc Engineering from the University of Moratuwa. He has received numerous accolades, including the Senior Multi Medal from the Institution of Chemical Engineers UK, the Dankworth Maxwell Award for the Best PhD Thesis at the Cambridge and multiple University of Moratuwa Research Awards. And also, Professor Ajith Alwis has served as a director of the University of Moratuwa Kargil's Food Process Development Incubator and chairman of the Engineering Research Unit. He was a science team leader at the Sri Lanka Institute of Nanotechnology and now serves as a project director of the Coordinating Secretariat for Science, Technology and Innovation Sri Lanka. Professor Ajith is an active member of several prestigious professional bodies, including the Cambridge Philosophical and Commonwealth Societies, the American Institute of Chemical Engineers, and the National Academy of Science, Sri Lanka. Additionally, he has served on the editorial board of the European Journal of Food and Bioproducts, and he is the founding president of the Sri Lanka Biogas Association. Finally, he has extensive publication records in international and local journals and contributes regularly to the daily feed on science, technology, and national development. So I cordially invite Professor Ajith Alwis to share his valuable thoughts in this webinar. Dear sir, over to you.
Thank you. Thank you, Sadeepa. I just a little correction. Now you introduced me as part of the cluster. Now, of course, I am today took the invitation come from National Innovation Agency, so which actually is the subsequently the cluster has been transformed into the state institute called National Innovation Agency. So talking about this topic of biomimicry and innovation. So I thought it's apt to indicate that now we have a National Innovation Agency that's in kind of promoting totally in the innovation segment for the economy. And apologies, though you shared the virtual backdrop, I can't get it. It was little fuzzy in the Apple, so I switched back to the normal. So apologies for that, not following your instructions. But with that, with thanks, I will try to start and share the screen. Is it visible?
Yes, sir.
Okay, so this is the third one in the series. Again, a big thank you for the invitation. So it's from the National Innovation Agency. And we say as our tagline is only innovation matters, and that's very important for Sri Lanka. And I'll try to bring that into this topic as well from the why innovation seriously matter for us as well. And down the line, it's sustainability. So essence of the topic is given is biomimicry for innovation. And I will look at Prof. Ranjith had the explanations, and so it's easy to follow him now. Yet I will also look at it again, maybe it reinforcing what was said and what probably you have heard for last 2 days as well. So biomimicry, it's interesting, quite interesting, I would say. And the word bio is about life, and mimicry or mimesis is about mimicking or imitation. And we know it's imitating life. So we're seriously looking at, from a bio perspective, a life perspective on everything that, why raising hands? The slides are not moving or? Sadeepa?
So we can see your slides. Now we can't see it.
Now can you?
Yes, sir. Now we can see.
Okay. Okay. So I don't know why the hand raised, I did see it. So this this whole process, it's important from our point to understand. I don't know if you look at the most, I see a significant number of participants today, also probably on these days. But most of us, I don't know whether we have a bio background or an engineering background. Now, this is where we do have an issue in Sri Lanka. And that stops a lot of progress being made, right? You know, at A level, we go from in one direction, and we do have a bio direction and a math direction. And this has seriously impacted our knowledge-based and our perceptions of how we understand scenarios. And it's been really a high time for us to change, but though we are still not changing. And when you look at this subject, it's seriously, we are trying to learn from nature and then trying to implement them in our day-to-day practices, entrepreneurship.
Excuse me, sir.
Yeah.
The slides are not moving.
Okay. Right, now it's okay, right?
Yeah, now it's
okay. No, I was not moving the other one.
Okay.
Okay. So so that's been one of our problems. And think about it. Because if you are doing to do imitation from learning from life and nature, there's a serious biology understanding that we have to do. And it's in those fundamentals that will give us clues. But it's our creativity from all the subject areas, which what we say as from a STEM perspective, not just one subject or zoology, botany, applied maths, and so on, but a very, very practical STEM application that we can do this change. And I think that is what we should understand from some of the examples that we have been talking about. And any of the examples that you hear now, also think about, now, am I in a position to think like this and change? Am I looking at nature in this mind? Or I'm just looking at just as a photograph. It's a beautiful color, beautiful feeling, sort of like that, rather than understanding the flow of matter, the exchanges at the interfaces between a something live and something biological with something else, from a macro life to micro life. And none of these things, are we really seeing that? And can we extract that information? Do we have the knowledge or the fundamentals or an interesting ability to grab some of that? Now, that's the question to ask. And this question, if we answer properly, most of us, including myself maybe, have to tell that no, I'm not having that. Why? Because I have spent my life, most of my life, ignoring a good portion of this knowledge and appreciation. We may appreciate nature, but we may not be able to understand nature because we have given up on that particular line of understanding. So today's problem for Sri Lanka, coming from National Innovation Agency, we are highlighting this every time, and I must put it here as well. The nation which does not create new things will not rise, right? It's important to understand this has been our failure. We have not contributed by way of doing different things and doing things differently. And as a result, we have lost our way. And as a nation, our standing in the world is not that great because we have not really contributed in the current context. Go back in history, scenario may have been different, but we can't run on that. We can only learn from why that happened, but we can't just go on talking about it. That's not going to save us anywhere, right? So we have to look at it, the current scenario, and we have to say, we have not done this. That's our problem. And the situation is, when we look at the Atlas of Economic Complexity of the Harvard University, is a wonderful website. I would recommend everybody to look at this. You can go through any of the countries that you want and compare to Sri Lanka. You can go through the timeline and see how things have changed in our export baskets, what we have been doing, who is buying ours and whatnot. And we have a very, very simple economy. And in this economy, when you see this export basket, we are actually using nature because we sell what we have. And it's very, very limited diversity that we have, a lot less knowledge being used. So none of the high technology exports we can find Even if you take ICT, that's the only one where probably the knowledge part is really utilized, and few in like activated carbon and in rubber. But you know, we cannot be happy about this situation. And you can compare Sri Lanka with Bangladesh and Vietnam and see those countries racing past us as they change their export basket. And for that to happen, we need to change. Now, of course, we have another issue: sustainability, climate change, our national determined contributions that we are going to have to deliver if we want to save ourselves. And that's collectively, we all in this one boat. And we should not sink. But most of the time, what we are doing is we are very likely to sink. That's a danger, but we want to work on this one. So let's admit that we have this problem. So when you look at very basically, this whole question about Prof. Ranjith indicated this, so I will indicate our pet slide that we always do. We need to have this basic research, and that research is not one subject dominated. And that's where we need teamwork coming in. Individually, we are interested in about a problem. So that problem can be solved using almost all subject areas. And then we maybe delve into subject areas that we are not even aware of by bringing other expertise, because we're very interested in a very creative solution. And then that basic research leads to applied research. Then, of course, we stress this. Even if you look at sustainability, when you look at triple bottom line and those pillars, from an entrepreneurship economic model, we do look at how do we protect our findings, because certain business models run on this aspect. Yes, we can democratize knowledge, but unfortunately, right now, unless broadly we all follow this model, we are going to suffer if we ignore this aspect. So it's important, whatever this research, we work on innovation, protection, and then subsequent exploitation through patents, etc. It's important for us. This is a huge, huge gap in the Sri Lankan context, and we are seriously failing here. And when you do that, it actually leads to significant wealth. Today, our wealth is not based on knowledge, no on innovation. Our wealth is, while other economies talk about capital markets, knowledge economy, information, and then all those sort of venture capital, angel funding, and then startups, including our neighboring India, they have about 100 odd unicorns. And that means unicorn mean $1 billion capital. And those 100 or 300 individuals, startup assuming to have 3 or 4 individuals, do have a much more of an economic strength than the whole of Sri Lanka. Just imagine that. And those would be kids of 30, 40 years old and so on, and most of them. And that's unicorns, right? And so we don't have a single one, and not a single one in sight either. So this wealth, part of it is we must plow back into basic research, and this virtuous cycle should continue for a country. And of course, the challenge is we do not have the freedom of the 1960s to follow a model like this, because we do have this sustainability question, climate change issue, and protecting the planet. But the essence of this process has not changed. Only it has added a little bit more complexity, that's all. And then comes biomimetics. Okay, we have a different pathway of doing the research, different even protection and generating wealth, which really won't upset our planet. So that's with us today, new knowledge, and we can work on it. So this wealth is permanent. This wealth is much more solid, and this wealth we can be proud of. Otherwise, we are looking at few tourists going here and there and then trying to get them, and somehow or other try to do things to get few more dollars while the rupee get weakened is not a way to grow. It's certainly not a way to grow. And that's why we will advocate in an innovation economy mindset. And this is a good time as any time to start looking at it, because we have hit the rock bottom. And it's time to demonstrate that our capabilities, we speak of high literacy, we speak of high ability, to demonstrate our abilities and change the economy. It's not about running away. And that's also important. So in this context, inventions do come in from basic and applied research. But we must take it to innovation. And that's where the wealth comes in. And in Sri Lanka, we do have these two words being messed up or not understood by most of the decision makers as well. And invention to innovation doesn't happen very easily. And we have probably a lot of inventors who have just carrying on certain certificates in their buckets, bags and so on, and wandering quite aimlessly sometimes, not knowing what to do. And so what happens is some of those ideas never deliver wealth because we have not converted it to innovation. In a very simple way, we talk about invention is about putting investments to generate knowledge. And innovation is putting knowledge to generate rupees. So that is the mantra of National Innovation Agency. We talk about research into rupees. And why we talk about rupees is we must have our rupees strong. So we don't speak about research into dollars. We speak about research into rupees, right? That doesn't mean work with a weaker currency or with a weaker mindset. We believe in a stronger process, right? So invention to innovation need to happen if we are to fulfill this wealth objective or positive economy objective. And if you do not have that economy, we are sinking anyway, right? And that's where our problem lies today. So we work on 5 innovation pillars. And so I highlighted as science and technology innovation, social innovation, eco-innovation, service innovation, and defense innovation. So these are the 5 innovation pillars that we have looked at. So to push Sri Lanka into an innovation economy. And when we talk about biomimetics, biomimicry and innovation, this innovation can support in almost all these under 5 pillars, because biomimetics or biomimicry is a resource pool for us to take knowledge to convert them to innovations. So it can cut across fine most, but dominated maybe by S&T innovation and eco-innovation. Eco-innovation definitely, because we are looking at sustainability today. That cannot be discounted, that cannot be ignored, whatever you do, whatever decision that you take. So eco-innovation is the basic. So we actually say today the mantra should not be just innovation, but eco-innovation. So we are conscious of what we are doing with the future generation in mind all the time, at all times, today and for tomorrow. So eco-innovation is like all-encompassing. But science and technology plays a very big role in transferring or generating this knowledge and so on. So these are the 5 pillars. So when you look at corporations, looking at the past, and we don't have any examples coming to from Sri Lanka to this, because Sri Lanka has really not shown many corporations. Now today we have a couple, but they have not fortunately failed, which is very good when they are thriving, who have the innovation mantra in their genes or in their board, but majority of our major companies do not have innovation in their mindset, which is sad, right? So they really do not have made a mark in the international sense. So we do have a lot of Me Too approaches, and we follow on business models, trusted, and we almost like serving the external markets, not dominating the external markets or not dominating any business landscape. We have only a few who believes in innovation, which is good. So this is a nice collection of 50 that's coming from externally. You can even see things like Kodak and so on, old corporations. They were innovators, but they fail to innovate consistently or continuously, and as a result, they fail. So the reason is innovation is crucial for systems to grow. And that has been the way the past has worked. That is the way the present is working. And that is also the way for the future as well. So innovation is the key. And that is why in Sri Lanka, we talk about innovation economy, because we really do not hear this word of innovation at all in our discussions, right? And IMF never tells us to innovate, right? They are model. Of course, there are value in what they say because you have to address the major issues immediately, but we have to think for ourselves as well. So while doing the things that are good, anti-corruption and all that sort of thing, we must also look at to grow. That prescription is not sufficient. To grow, we need the innovation prescription. Fine. Okay. Now let's turn to how biomimicry comes in for this innovation. And here, as we said, we are going to imitate nature. We are going to imitate the external life as we see. And we see many life forms, those who have evolved under so many years. And these are not just 1,000 years. We are talking about billions of years as well, right? So if you take the Earth and the systems, we can talk about 4.5 billion years. We can talk of life forms for 3.5 billion years. And a good Homo sapien, we can only speak of 30,000 years plus, right? So once you become the agriculture man. So, so that is something about the mother nature and the father time. And we say evolution is the best engineer we have, right? Because as we evolve, as we change, we have to address problems. And in the natural world, addressing these problems strengthen you in various ways, in adaptation, in adapting, and in overcoming the challenges posed by the external problems. So this is the beauty that we can understand from natural evolution over these billions or millions of years. And the point is learning from that evolution, the engineering that happened with evolution, right? And how I can do. So we must also understand we have some special attributes as human beings, but the rest of nature also has some significant attributes honed over many, many millions of years. So when you look at it as we all as animals, we have some unique characteristics, but we know we are not the fastest, we are not the strongest, we are not the kind of like most sensitive to sound. We have limitations. So you can look around and find few animals who have in certain areas much better than us as human beings. Our strength, however, is this ability to design, ability to be creative, ability to understand, and analytical ability. So we do have this specific development of the brain, maybe the prefrontal cortex from the reptilian brain that we share with the animals at the back of our heads, right? So that's why probably in this century, we are really, even though we are studying stars and supernova and stuff like that, we have suddenly decided to study our own brains, right? So this is another industrial revolution that is taking right now is this neurotechnology revolution. It's all about cyber and is looking at computing and looking at brain and then try to simulate and emulate and so on, and then try to understand brain because we lot less understand about our own brain. So taking these characteristics of ourselves as the design animal, an animal who can do design and design well, but we want to draw in these strengths of the rest of the animal kingdom, rest of the plant kingdom, basically the life. And this is what biomimicry is about, right? And to understand this life, we need to understand almost all other subject areas, which we are now developing. So if we partition ourselves, no, I'm not interested in this subject. I'm not interested in this subject. I can only do this calculation. I'm not interested in trying to remember. Again, we really misunderstand the subject by thinking these are for memory and these are for calculations. It's not. It's all about understanding, and understanding gives you that foundation. So it's important for us to understand with this why we learn, why we study, why we look at and observe. And it's important for us to see. So you look at, you will find many examples from dogs to sharks to peacocks to rattlesnakes to bats. They have some strength which we don't have, right? But today we have examples of using those specific skills of the peacock to the shark, to the bat, to the rattlesnake, to the dog. We are trying to bring some of those habits to serve us. And that's biomimicry, right? Probably Israel was saved at one point because they understood the rattlesnake is special ability to home into a prey using sensing heat or sensing the temperature. And that is what came up at the Sidewinder missile, right? And that was an Israeli military discussion at one point, huddle discussion. What am I to do? We have a problem. We must come out with something. And they came out with this. So you can see it's an innovation. They understood the rattlesnake. They understood this ability to home into a prey through their sensing the temperature. Then they decide, why don't we target the exhaust of the airplane using a missile, a heat-seeking missile? So you're mimicking the rattlesnake behavior. So similarly, you have shark. We have looked at shark skin, and then we have done the swimsuit in Sri Lanka for Olympic, and Peter Phelps won these awards. But thereafter, the Olympic Committee said, no, this has to be disallowed because that's going to unfair advantage. We are now looking at peacock feathers and looking at solar arrays. We know with bats and radar. We know with bloodhound how to sense the olfactory nerves, understanding it. I'll come to that again. So there are a lot of examples from nature that we can bring and bring products. And today we speak with that knowledge. So I want to take a couple of minutes, a couple of ideas just to give that what is biomimicry and what is not biomimicry. So we see this very excellent development by humans on flying. But the more as we evolved, we observed birds and we were very keen to fly as well. And in Greek mythology, we have Icarus, who just tried to mimic putting wings and try to fly. Of course, met with death. But when finally the Wright brothers came up with the plane, they were not flapping wings, so they were not really copying the birds, right? So they understood it differently, and they look at the Bernoulli's principles, the lift effect, and the design, and then they started the human engineered flights. So though we wish to be on biomimicry, we came up with an engineered solution of our own, how to do that, right? Now that's different from that biomimicry. Then we do lots of wastewater treatment plants and so on. And we say, okay, in secondary treatment or biological treatment, we use bugs. In biotechnology, we say, if the bugs can do it, why do it yourself? Get the bugs to do it and enjoy your free time. That is not biomimicry either, because that is what we call as bioassisted work, right? We understand what they can do and make use of them. So we do not augment and mimic that ability in a system that we develop and say, look, this is what we are mimicking, that life form. So understand these differences as well. This is a subjective understanding. I mean, that doesn't mean what we are doing in biological treatment is no way secondary to what we are doing. But there's a greater interest when you talk about biomimicry, because we extract things and then implant, develop, imitate. But this imitation is not that easy, and we get our work done, right? So I initially looked at, when I came across this, it was through this book, which of course is not purely on biomimicry. It's on bioeconomy, right? And the blue economy. Now we have a different meaning to the blue economy with mangroves and sea and all that coming in. But when the Club of Rome came up with this book, it was about more eco-friendly, completely sustainable models. And the projects were like, for 10 years, 100 innovations, 100 million jobs inspired by nature. So the nature inspiration was there, which is also fundamental to biomimicry, because we are looking at becoming inspired by nature. But of course, as time evolved, this is where we are, because we found that Janine Benyus really gave which Prof. Ranjith indicated, her 3 ways of looking at it. And we have this biomimicry first book that kind of made up fantastic reading, right? The first one is also fantastic reading. I mean, there's so much we can do. But in neither of these, Sri Lanka have figures. So which is bad, right? And I don't think we have also included ourselves in the Ray of Hope competition, which is globally done, which carries 100,000 USD. We have been talking about it somehow or other to get in. And I'm just showing this Green Pod Labs, which won a couple of years back, coming from India, which is of really value to Sri Lanka. I thought I will touch it depending on time. And they look at, so Janine has this Ray of Hope accelerator, which really looked at taking this, not just finding from nature, but the lessons from nature to the business. So I would encourage everybody to look at this Ray of Hope and look at what they have done and the things what people have won and see how we can make use of it. I can certainly think for Sri Lanka, the Green Pod Labs, what we can do for Sri Lanka, because they are talking about $12 billion food loss. And that's exactly our export income, right? And we lose so much in our 50%, 40 to 50% of our food as well as we produce, which we can't afford. So this is where, and I take a few minutes to please listen to this, which of course, Professor Ranjith had it, but let me go through it.
Where I'm sitting right now in my house is about a mile or so away from some train tracks. So from time to time, I get to hear a nice little train rumble in the background. It's not a problem or anything. It doesn't happen that often, and when it does, it's just some mild background noise. But I always wonder about the people who live right next to these train tracks. Like, it must be a lot worse for them. But even that is nothing compared to what some people had to experience in Japan in 1989. Japan is a world leader in high-speed trains, especially maglev trains that cut down on friction and travel at hundreds of miles an hour. So fast, in fact, that they were causing a kind of sonic boom. Okay, so it's not like a real sonic boom because they weren't breaking the speed of sound or anything, but as they were going through tunnels, they were going so fast that they were compressing the air in front of them so that when they exited the tunnels, it did kind of make an explosive noise. So yeah, imagine living in an apartment right next to the opening of a tunnel and hearing what basically sounds like a cannon going off several times a day. So people complained about it, obviously, and the trains were forced to slow down, which kind of defeats the purpose of having a high-speed train. Engineers set forth working on the problem, most of which required redesigning the tunnels in some way, which had been a huge construction project. But one engineer named Eiji Nakatsu had a different idea. Turned out he was also an avid bird watcher, and one of his favorite birds was the kingfisher. Kingfishers eat fish, hence the name. And they do it by flying over water, finding a school of fish, zeroing in on the one they want, and then dive bombing into the water at full speed. It's actually kind of insane. And these birds are designed to do this and create as little splash as possible to make this hunting more effective. And Nakatsu recognized that these birds were kind of doing the same thing that these high-speed trains were doing. They were moving from one medium to another. Birds obviously are going from air to water, but these trains were going from low pressure to high pressure, so similar idea. So he used the shape of the kingfisher's beak as a model and used that to redesign the front of the train. And it worked. Not only did it cut down on noise, but it made it 15% more efficient and 10% faster. This is an amazing example of lateral thinking, but it's also a great example of a design philosophy known as biomimicry.
So I suppose that gets an idea about, but there's a hidden point that you should also take. That was an engineer who was doing bird watching, right? So he was connected to the biological world or the life. And when the problem came, he was able to extract that information or look at critically think about it and enable him to really move into a solution. Now, that's when I said, getting the fundamentals, having this broad awareness is a key if you are to succeed in biomimicry with innovation, right? Otherwise, we have to have partnerships. But then even to appreciate what others bring to the table, we still need to have this broad understanding. And unfortunately, in Sri Lanka, I would say this is something we seriously lack. Okay, the next example is another interesting one, which also captured the imagination in the very early stages, is this termite mound, which again, from civil engineering, and I'm pretty sure this will be taken up tomorrow or the next lecture as well. People who is a designer, architect, came up with, looking at the termite mound, coming up with a different building. And therein, I have a question on innovation. Because you study, you look at it, and you study, And typically when you do a building design, specifically a more green building design, you would be doing all these things, understanding the microclimate, looking at these three-dimensional systems, coming it down to into a two-dimensional ways of presenting data and understanding it from a 360-degree perspective of how the solar sun paths and wind directions, variations, soil, which was mentioned again in the by Prof. Ranjith. And then you suddenly see termites have done it in a different way. And even though the temperature externally is varying, internally it's constant. They manage to keep it. And they don't have any moving parts. They do it without any moving parts by the sheer design. And for us to do that, we will need a lot of moving parts and stuff like that. When you have moving parts, you know there's a time limit. They can fail at some point, right? So we had this type of designers and 3 architects, 2 from Sweden doing the modeling. One is a Zimbabwean designer who was considered the initiator, Mike Pierce, the first picture. And 3 came together, did the model, and came up with this building, right? Passive climate control in Eastgate building. Now they were showcasing with this building, okay, the floor area is a brand new building, the office space is cheaper, no AC, but very comfortable. Rest of the other buildings around the place, it's more costly. And the question I would like to ask is, with this knowledge, why we don't basically go into these buildings all the time? And we talk about climate change. We talk about 1.5 degree rise. We know we are now 1.4. We are going to surpass this 1.5. We are into a huge mess in time to come. But knowing all this, we still do the wrong thing. And this is an example. We don't have very many buildings of this nature. With all this knowledge, we don't do that in Sri Lanka, right? We have not done anything of this. So what's the secret? But of course, coming from the Green Building Council, you know, we are a significant player in the green building market, having done quite a lot. And probably in the textile and apparel sector, we are the #1 country in the world to have the highest density of textile factories, green buildings in the world. But overall context, we know our building energy consumption is still high, but we don't have something like seminal, something interesting to showcase to the outside. And this need not be. We can probably have some extra different knowledges. And coming back to termite, I also like to say that, you know, these termites bring the soil from way down. And this is also a good one to study the mineralogy, what's there way below, a very easy way rather than drilling and doing that. So that's a little bit of a bio-assisted way of understanding the compositions, and maybe gold is in there or some other unknown minerals and stuff. And termites gives us a way to get some really quick data. Okay, so these are examples that again was discussed, like lotus effect and Salvinia effect, coming from one botanist and one from Karlsruhe, the Salvinia effect. But Dr. Wilhelm worked in both. Very simple. Sri Lanka has both this lotus as well as Salvinia. You know, we have not done it like this. So there the point was going and studying. And one is observation. When you put Salvinia into a glass of water, you will find this silver effect. And somebody has a more deeper interest to ask, what is happening there? Why this silver color? And then to identify, there is this trapped air layer under pressure, and the plant is capable of keeping that. Of course, we know about the lotus effect. And with nanotechnology, that is one of the favorites that we always showcase. But Salvinia effect is little new, right? And then you have lotus effect, Salvinia effect, petal effect, and so on, where we go into superhydrophobicity and so on. So it's all learning from nature. But the point is, we can today study these structures because we now have ability to go down to the atom level, ability to go down into these biological species at different level and study their microstructures. And we do have the ability to actually develop these microstructures on different surfaces by ourselves, by design. Now that is where we shine as a human being, right? So there's so much out there we can bring in. And one thing that is coming out with Salvinia is applying it on ships, maritime ships, and companies air coat, and then trying to see you reduce your fuel requirement. Because of that air layer, you get passage without much friction and thus reduce the use of fuel. And it's a huge plus for the climate change. And just imagine the Salvinia plant showcasing a way forward for a climate crisis, because marine shipping accounts for a huge amount of transport for goods and services that we every day depends on, right? Now, of course, the most fundamental of the best case that we always talk about in biomimicry is Velcro. And this happened in 1941 when an engineer, again, George Mestral, went around a walk with his dog and found the stuff sticking to his trousers and stuff. And that was his burr, like Tutiri. Of course, he had the interest to study it under a microscope. And we are talking about 1940s. So he had the limited microscopy, but of course, strong enough, the magnification. He found this loop and hook stuff. And that's what he went ahead and designed. And today, if you look at Velcro, supported by the famous French designer, Pierre Cardin, and then, of course, fundamentally supported by NASA for their space program, because they wanted to keep things kind of without floating. And Velcro was a fantastic supporting thing. So you can see these industries, multiple industries in multiple places, simple, original nature discovery turned into a product and innovated to be a fantastic, useful item and basically taking over the world in multiple areas. So very interesting, right? The point is you need to observe. Then you must have a very creative mind, or scientific analytical mind, to put it under, and then to think, what can I make use of this, and then to produce and then have the business model. So you can see the necessary steps. That's where we talk about invention to innovation, right? So Velcro is famous. Again, looking at the lotus effect like that, this is a situation where one of the best products of nanotechnology products of which came up from the peach fruit. The science engineer was washing this peach fruit and saw the kind of like the whiskers sitting on the surface, and he just implanted the concept of whiskers onto the polymer matrix, and thereby getting the water repellency effect on the matrix and the textile. And you can see his or rather the peach inspired textiles which will not get wet. Now, something similar we did in Sri Lanka also with titanium dioxide nanoparticles, and gave this kind of like, you don't need to wash these clothes, you can use in a UV cupboard. But invention did happen, but innovation did not happen because our textile industry was not interested. Now you can see the difference between sometimes a decent idea, something useful, something kind of revolutionary. To get into an innovation, you still have to cross multiple problem areas, funding, industry interest, market opportunities, and so on, and talking about the cost as well. So this is at the moment is still expensive, but you know, there's market in multiple countries. He has been able to sell or license his technology. So invention to innovation is that idea creativity. Now in biomimicry and innovation, this creativity comes from mimicking nature, understanding from nature. So you can look at multiple things. Then you need to carry that into research, and that's where you put it in the scanning electron microscope or whatever, and then study it in depth. Then you look at how to transform your polymer materials into have this surface characteristics, bring the butterfly effect into your textile. So the peacock feathers into a solar cell, or the shark surface into a textile swimsuit. So you can see you need to transfer that, and that doesn't come automatically because you understand the shark skin is different. It happens because once you get to that understanding, you have to do that research and development. Then you need to take it to that innovation, commercialization stage. And that is a teamwork, right? We keep on talking about this as a teamwork. So this is why innovation is key if you want to do this change. Innovation is a central driver of economic growth, development, and better jobs. Please, we need to understand that. And Sri Lanka fails in this part. However good ideas and things happen, we do not look favorably doing things. we follow the Me Too or very risk-averse method of working. So people continuously look at doing great things with biology today. And sometimes advice is embed a biologist in your engineering design team and go out in that team, because you may lack, and certainly in Sri Lanka we lack, right? And so maybe our Linus Prize award winner, Engineer Pethiagoda is almost a global exception in Sri Lanka, who probably understand biology more than now as a biomedical engineer. So now there you can learn a lot by how much of time that he has got into this biology. And then now, but what we need to look at more is getting that biology knowledge more into how to do the biomimicry. At this stage, what he has been doing is the bio knowledge generation. What we must work out is how do you gather that insights to make into products. So these are like fruit fly and a parasitic fly, two different things, but trying to do two different things. About one is on Drosophila melanogaster is a fruit fly, and it's all about his olfactory nerves, right? Because that can sense, and you can see the neurons triggering, because when different smell cuts are common, and people are now looking at testing chemicals, air pollution, explosive materials, and so on, by looking at the specific proteins and then getting them into biosensors. So this fly is showing that. Then if you take Omiocrea, which is a fruit parasitic fly, who actually lay, the female larvae is on the cricket, and what they have found is their membranes, or the ears hearing, is about, the two ears are basically about 1 or 2 millimeters apart. So our human ears, you know, it's about 30,000 times this parasitic fly's ears. So we know from what direction the sound comes, because our ears are so far apart. But yet this parasitic fly, ears are so close together, still ability to differentiate is about 2 degrees, better than humans in that. So people are looking at from this, how do you get into microphones and stuff like that, and these new devices. This is this little old stuff in some way, because they have now moved into devices. That's what I want to give. It's not a new finding. People have literally, so it's a practical example of moving into innovation. So you find now mimicking the fly and mimicking the specific biological mechanism of detecting something direction at that specific 2 degree specificity. How can you bring it into a very specific microphones or stuff into the mobile phones and things like that? So you can see a parasitic fly, a fruit fly, serving different needs. And then scenarios like this, Darwin used to collect butterflies. It was a science exercise for them in the university. And one such finding was a bombardier beetle who was having 2 different chemicals, hydrogen peroxide and hydroquinone in 2 things. And then he shoot off with a cavitation, kind of understanding a mechanism of generating propulsion, a chemically induced propulsion, right? What is interesting is the desert beetle, how to collect humidity from the microstructures on the body, because the beetle gets water to drink from the body that drops coalesce and comes down, and she's able to suck it up. So it's quite interesting number of beetles, and probably an interesting beetle is this, right? The rhinoceros beetle, and you have these the other beetles that are of having these exoskeletons, which is of course chitin. And you know, we can work with chitin and nanotechnology. That's a different all issues when we take prawn shells, crab shells, and so on, and then try to get chitosan and nanomaterials and all this stuff. But here, because it's biomimicry, what we learn is this beetle has an exoskeleton which enables them to weigh or lift weights much, much more than their body weight, right? Okay, now that's a seriously different understanding. So why not we try to elevate ourselves, because ordinarily a human can take 50% of you can lift that one, and you can't continuously go on lifting. Now here you start imagining, why don't we empower ourselves with an exoskeleton and we start lifting more than our body weight? And wow, then productivity changes seriously. I don't have to have an effort in lifting this. My spine is different. And of course, on the other side, I also can say goodbye to wheelchairs. And you know, this is happening, right? And beetles paved the way. The rhinoceros beetle and so on paved the way to this development. So it's very, very interesting to see how the developments have to come from the animal world or the biological world to come to this point. So again, what you get, you can go on giving examples, but the point is looking at this, the Namibia desert beetle is like, okay, how do you get? You get the coalescence, humidity comes on this, and then coalesce, then flow it on, and you get water. And today we have fog nets, and where we can actually, we do certain patterning surfaces and get the wind will go, wind will carry humidity, and we harvest water from air. And harvesting water from air, we keep our buckets below, and sometimes the villagers get their water. So this is happening in real time in some places of the world. So can you upscale it? Can you do it in different, because you know we have very much high humidity. I can put in a water cooler and try to get it. You have different machines with moving parts today doing that, but I'm not talking about it. I'm talking about the biomimicry into innovation. So the beetles have shown us a way to do that. So recently there was this fantastic discovery of sort or observation where plastics were from the beeswax, the waxworms coming out was actually one of these scientists who was actually a bee farmer in a spare time, put a couple of these worms into a cellophane polythene bag and kept it, and found in the morning the worms have gone through the bag. And that was a what you call the eureka moment of sort, because they have eaten through the polymer. And here then started, there was a huge amount of research that immediately started on getting these chemicals and upscaling it to take care of the plastic issue. So here it's very simple. This Galleria minerella, you can see the pond, and then the chemicals that they exude and can look at create or rather consuming plastics. Of course, you know, you can't create this worm and then talk about creating the plastics away. That is too slow. The kinetics won't help us to scale. So what we will again do is we'll look at the specific chemicals in the enzymes, the saliva, and so on, and then try to scale up in the way we do processes, right? So biomimicking, imitating some of the compounds, and so on. So somebody said there's no greater joy than studying nature, but the point here is not looking at studying nature. We are looking at studying nature in terms of mimicking. So how many times we have seen this effect on a lotus leaf, but how many of us have really gotten converted into a commercial opportunity, right? Similarly with salvinia. So something to think about. And this is that scenario very simply, very quickly, looking at India, just to end before that.
Food, which does not make any sense.
In India, 40% of what is being produced is lost before it goes to the end consumer. Food waste is a preventable problem. The solution lies in not growing more, but to conserve what is already being produced.
The solution that we provide is holistic, and the technology is inspired by nature.
In developed countries, there's an extensive amount of cold storage and cold supply chain already available. But in developing countries like India and other parts of Africa and Asia, cold storage is negligible. We have developed shelf life extension sachets that contain several plant extracts and plant polymers. Our product can extend the shelf life at room temperatures 40 to 60% during transport and storage. We're able to significantly cut down the carbon footprint. I'm Deepak Rajmogan, founder and CEO of Green Power Labs.
Fruit is a perishable product. The inherent nature of fruit itself makes it challenging to put it in the supply chain.
India is the second largest producer of fruits and vegetables. We grow a lot of varieties of fruits. So for example, grapes that are produced in central India travels to the northeast India, which takes about 7 to 8 days. It has to travel in the ambient condition. And grapes, as you know, is a highly delicate commodity. So we are trying to solve this problem, ensuring that the stock of the grapes are fresh till it reaches the end consumer. I'm Vijay. I'm the Chief Business Officer for GreenPod Labs.
Food generally goes off because of spoilage microorganisms. So we identified different defense mechanisms that is present inside fruits and vegetables and the ways of activating it.
These defense mechanisms are very similar to a human immune system. They get activated when there's external stress, be it a biotic stress due to microbes and other pests, or abiotic stress due to temperatures and humidity. So we've replicated this communication system into our product.
So right now we have some mangoes, and here we have the treated one with the sachet. I am Dr. Shankar. I am R&D Director with GreenPod Labs. All we have to do is just drop the sachets into this crate. That powder is encapsulated with plant extracts and it gets saturated into this crate environment. The sachet material outside acts as a barrier through which these volatiles are released. So there is a significant difference in the spoilage. So we can see the spoiled mangoes here, and here the mangoes are actually fresh. So how does the sachet activate the defense mechanism? Fruits and vegetables, they communicate with each other before harvest when they are with the mother plant. They always get those healthy signals. So what our sachet does is give these signals that the crop receives from the mother plant. And these signals actually activate the defense mechanism inside. So our formulation works by strengthening the cell.
So I'll stop with that because I just want to communicate that what they have done is very interesting, right? They were a winner in 1 year for the Biomimicry Institute International Awards, and you can see how relevant that is for us as well, right? We can immediately, but that just looking at the biochemistry and understanding from that, and then looking at the signals, and then coming up with the concoction of extracts, then sending or mimicking back the stuff to behave in the way that they would have behaved in nature. So it's a $12 billion kind of like looking at a solution to a problem that the country is facing. So this is the kind of like what I want to talk about, right? So biomimicry, the concept of looking at nature and getting those very specifics because we have a healthy interest in understanding how things go on. Then looking at what we lack, our problem, but seeing how this nature has responded to via evolution to solve that problem and to empower it, and then take that empowerment to our benefit, take it out, do it, and then translate it to so that it works for us. So we have a selfish motive, right? But the point is, as we are learning from evolution and taking those lessons, and that's why that type of innovation is actually co-innovation and is quite sustainably supported, right? Rather than looking at things that we need to come out completely differently, we actually work against nature, right? So similarly, considering the fact Sri Lanka has not really shown much in biomimicry and innovation consequently, let's look at innovation as for our innovation economy, right? So get nature inspired, because we are a biological hotspot. There's a tremendous amount of stuff inside with us that we are not looking. Just pure appreciation of nature is not what I'm talking about. Looking at our problems like this green pod in India looked at, and then taking it back and solving our issue after an issue. And that transformation is very valuable. So thank you. That's where I want to conclude.
Answer. So if you have any question related to today's session, so now you can ask the question. You can mute your microphone. Ask the question.
Good evening, sir.
Yes.
Yes, sir. From last couple of, 2-3 days, we've been talking about termite mounds and kingfisher, honeycomb, velcro, or peach, which is inspiring us to biomimic basically. But then looking at the population that is increasing day by day, and Earth which is shrinking, uh, do we really think that this thing would work in that scenario globally, or would be applied in all various geographical locations?
Well, I would say that now, if you look at the current figures in a hard way, very simply, if you take the planetary boundaries, forget about 7 of it, just only looking at climate change, the simple accounting will indicate that we are continuously going the wrong direction. I suppose that is, you cannot argue against that. So you need to have answers to this, and you need, so what we are talking about from biomimicry is a fantastically more nature friendly or inspired by nature mechanism of getting our things done. And then whatever we do is not going against. So if you take the termite mound, for instance, if you look at the buildings, we do our air conditioning in a silent way, in a sense, by the design without any moving parts. So take some of those alien mechanical items that we used to do as moving parts, you move them away, you design it in so that you keep the environment. So don't you think that's more beneficial? We want to live differently. We talk about it as higher quality of life, and we achieve it in a different manner. Because at the moment, we try to change everything, or we fight it out with the surrounding and try to impose our own mechanism. And so this is not probably the total solution. I'm pretty sure SDG 12, which is sustainable consumption and production, has to come in if we are to solve. So this is a part of the solution. This is not the full solution, but this is a brilliant solution because we respect nature and take decisions based on nature rather than trying to say, no, we humans are superior. We can come what may, we can come out with a solution in whatever the way possible. But we know in the long run, that solution has a problem. So that's the way to look at it in my view. But whether we find our answers fast enough to solve the issue, I doubt it as well. I share your concern there.
Yes, sir. Sir, one more thing. I mean, the way we've been looking at this or going through with the webinar, what I've found out is that coastal areas, you'll find coconut or palm trees. In desert areas, you'll find cactus predominantly. And coming up towards, say, Himalayan range or something, the Devdar trees or conifer vegetation is there. So going back to basics, if we talk about, say, 100, 150 years back, all the things were planned in that way. Things were happening in that way. The more flatter structures and deserts were seen. In mountainous regions, you'll find tin kind of structures which were being built so that snowfall can be taken care of. And similarly, so are we looking forward to going back to that kind of basics once again, or how do we go ahead with this?
Yeah, now that's, I hardly doubt that anybody would agree on most of the time in going back to completely reversing the direction. But how do you do that? What you call like a spiral learning. Spiral learning, you learn and they come back, but to a little different position. Because we have a certain different idea about what we call as quality of life. So careful examination of what exactly the activities we are still addicted to or accustomed to and aspire to. So I doubt whether we take a decision in going back for sure. But definitely we definitely have to. I don't think there's any question about modifying the way we do things. That modification has to happen, you see. So the point is how we can whether we will be strong enough to scale up along these lines to get what we like to have, and in a different way without compromising the growth. So my simple answer is, I doubt very much we will go back. We will rather go extinct than going backward.
Great, sir. So then my summation would be that locally in various regions, research on on biomimic should be done or should be initiated, so that more fruitful results or more fruitful things may come in any varied fields, basically.
Yeah. Remember that I mentioned about, that's where the innovation comes in, right? Look at new ideas. Now, there's lots of ideas. If you look at the compilation of even forgetting about the Janine's biomimicry and the things that have happened so far, going back into this Club of Rome book of Blue Economy, most of those practices have not really evolved into become major practices in the world. You have to ask the question, why? So we seems to be taking lot less awareness and understanding of the need to act differently, need to consume differently. We follow the old practices, which are convenient, which are pushed down our throat. The economy pushes us to embrace those things. That is what is rewarded. So these challenges are there, right? So are we capable now? Now I said about the buildings. How many buildings from Zimbabwe you can find out these climate friendly buildings of this nature without AC and so on, mimicking. You find one or two in Sweden, you find one or two in London and in few places, but that has not gone mainstream. So definitely it's not innovated. It's proof of concept shown, few examples are there, but you don't have the full business model saying, look, we will do this building as a matter of our construction mechanism, and this is the building that we are going to give you. I don't think we have a kind of like yellow pages, I can go and get this type of termite inspired building set up in Colombo.
Fair enough, sir. So basically, a bit more research needs to be done, and or maybe that's where we would pitch in with your great ideas.
Yep, SDG 12.
Lovely, sir. Thank you very much, sir.
Thank you.
Okay. Thank you very much, Esteemed, for your insightful session. Your perspective on biomimicry and innovation have provided us with that valuable knowledge. And we would also like to extend our heartfelt thanks once again, Professor Ranjith Dissanayake and Professor Ajith Alwis. Again, Professor Ajith Alwis also. Your contribution are greatly appreciated for this webinar. And of course, thank you to all our participants for joining us and for your enthusiastic engagement throughout the webinar. And we are excited to invite you to join us again tomorrow with our next session on biomimicry in construction conducted by Professor Janaka Ruwanpura. So thank you once again, and we look forward to seeing you tomorrow. Good night, all.
Thank you.
Good night.
Good night.
Good night. Thank you, sir.
Good night.
Thank you, sir.